In Module 3, Lesson 12, we're going to look at the properties of inequalities. First of all, the description of preserving the inequality symbol that means that the inequality symbol stays the same. So, of course, reversing the inequality symbol means the inequality symbol switches less than with greater than, and less than or equal to with greater than or equal to. And these go both ways. It can switch the greater than with less than. This is back and forth. So there'll be a station activity. And in the station activity, what you will do is go to the station, take the two cubes that are provided. The cubes have different integers on them. You will roll each die, recording the numbers under the first and third columns. First and third columns. And then write an inequality symbol that makes the statement true. So you'll see in this first example, the first die had -3, the second one had 5, and the inequality symbol was less than. -3 is less than 5. Next, you will perform the operation that is listed in the next column. And so the new inequality is -3 plus 2 is less than 5 plus 2. And you do it to both sides of the inequality. And when you perform that, you get -1 is less than 7. If this is true, then we say that the inequality symbol was preserved. If for some reason this changes and it is no longer true, we will say that the inequality symbol was reversed, because we will have to change our symbol to make it true. Okay, again, just as a reminder, when you solve the expressions on either side of your inequality symbol, you need to write the correct inequality symbol comparing your two integers. And if that inequality symbol has to change, you will say that the inequality symbol is reversed. To illustrate again, I'd like you to take a look at station 2. The result on die 1 was -3, and die 2 was 4, and -3 is less than 4. Then the operation was to multiply both sides by -1. -1 times -3 is +3, and -1 times 4 is -4. So when we look at the resulting inequality, if we kept the sign the same, it would say 3 is less than -4. And that is not true. So we change or reverse the less than sign to make it 3 is greater than -4, which is a true statement. So in our last column, we record that we had to reverse the inequality symbol. In station 3, looking at our example again, die 1 has -2, Die 2 has negative 4, and negative 2 is greater than negative 4. And then we're asked to multiply both sides by 1/2. So negative 2 times 1/2 is negative 1, and negative 4 times 1/2 is negative 2. And negative 1 is greater than negative 2. So our inequality symbol was preserved. And then in station 4, we have 3 on our first die, negative 2 on our second die, and 3 is greater than negative 2. We're asked to multiply by negative 2. So 3 times negative 2 is negative 6. Negative 2 times negative 2 is positive 4. Negative 6 is less than positive 4. So we had to reverse the sign. Once you have completed all of the stations, and if you don't have access to the die because you're not in class, you certainly can choose integers. I suggest that you don't have any integers larger than 7 or its opposite, negative 7. Nothing with an absolute value more than 7. And then you need to go back through and determine the operation and new inequality which preserves the inequality symbol. Go back through the stations and say which operations preserve the inequality symbol. And then put in which operations reverse the inequality symbol and give an explanation. And please do that for every example in this table, because what we're going to find is that there is a rule to follow. And you need to be able to have a strong rule, which is why I'm not going to give it to you in this particular lesson.